So we have this slide here that reminds us of the formula to calculate marginal revenue. And on the next slide, we're going to see a table that gives an example. And we've gone over some of these examples of marginal analysis in the past, but it's worth revisiting here to build towards what the marginal revenue curve looks like for monopolists. Remember, with perfect competition, the marginal revenue curve was a flat line that was equal to the price at all quantities, because the perceived demand curve for perfect competitors is a flat line. It's a perfectly elastic demand. So price and marginal revenue, it mathematically works out. If you take the change in total revenue divided by the change in quantity, you're going to get the same number for every quantity in perfect competition. But that's not the case for monopolists. So we're reminding ourselves of the formula. You take the total revenue from the last quantity level, and you subtract that from the total revenue from the next. You subtract the next quantity's total revenue. That's the Greek letter delta, the change in total revenue, and you divide it by the change in quantity. We often skip this step if the quantity jumps are 1, because it's always going to be change in quantity of 1. You divide by 1, you just have this. But it's important to keep in mind, as we see in the next slide, the changes in quantity here are not 1. It goes from 0 to 10, if we assume that it was 0 before. Then from 10 to 15 to 20, they're changes of 5. And we have different prices. And this is actually a demand schedule, which this is why we're revisiting this for monopolies. The perceived demand curve for monopolies is the market demand curve, because they are the market. So at a price of 10 per unit, quantity demanded is 10 in the market. Drop that price by $1. Quantity demanded rises by 5, etc. So the total revenue, price times quantity, 10 times 10 equals 100. Over here, 9 times 15 gives us a total revenue of 135. And then, of course, 8 times 20 gives us a total revenue of 160. The change in total revenue, let's start from 0 to 100, is 100. The change in quantity goes from 0 to 10. So the marginal revenue isn't 100, it's 100 divided by 10, which is just 10. The marginal revenue of going from 0 units to 10 is $10. The marginal revenue of going from this level, 10 units, dropping the price by 1 to 15 units, is 135. And this is why marginal revenue for monopolists is different from perfect competition. In perfect competition, you drop that price. Yeah, your quantity demanded goes here, but your costs are going to be too high and you're going to go out of business. And you're not going to do this drop from 10 to 9. You're also not going to increase your price from 9 to 10, because you're not going to see a drop in demand from 15 to 10, which for a monopolist, it might be worth losing these 5 sales. You just don't produce those 5 units, but you get 10 for each unit, and that might actually be better for you as a monopolist, as we'll see. Can't do that if you're a perfect competitor. You raise that price, the market may say there are 10 people who will still stay in the market if that's the market price, but that's not going to be the market price. Everybody's still charging 9. You're going to lose all your business. So your marginal revenue is whatever the price is. And if you did the math here by holding the price constant for all quantities, then you would see basically the same thing. So here, monopolies can change the price and change the quantities and still have positive sales and still pay their bills in many cases. So at this change in revenue, 135 minus 100, we have to divide by 5 to get 35 divided by 5 equals 7 is the marginal revenue. And then over here, 135 to 160, the difference there divided by another change in 5 gives us a marginal revenue of 5. So you notice marginal revenue is declining as price declines in this scenario. But what you also might notice is when you link it to the demand curve here at that first unit here, that first area where you have some demand, and we're assuming that a price any higher than 10, quantity demanded just drops off to 0. Quantity demanded and marginal revenue are the same number, but then after that, marginal revenue is below quantity demanded at all points. And this happens in all monopolies. So look at this graphically. The demand curve from that previous chart, these are the points that we saw in the previous chart as far as the quantities demanded at the different prices. You plot out the marginal revenues here, you get a line that is always beneath the demand curve. So when we sketch a graph of a pure monopolist, cost curves and revenue curves and all the curves that we used in perfect competition to decide optimal quantities and prices, when we do this for monopolists, remember the marginal revenue curve, marginal revenue equals marginal cost. That's where you maximize profits. We'll see that again here too. This curve is where we want to link this up with the marginal cost curve to figure out what our quantity should be. This curve is still going to be important for figuring out the price, but they're always going to look like this, where that marginal revenue curve is always beneath the demand curve at every quantity except for, of course, that first one. So, back to that question that we asked with perfect competition. You need to figure out the quantity and you need to figure out the price. Every market structure, we're going to have the question of how do you determine quantity, how do you determine price. Same equation is going to determine the quantity every time. Price is going to be a little different in different markets. So we're asking that here too. We already know how to determine the quantity. We just need to figure it out from a different looking graph, but marginal cost equals marginal revenue. I already just mentioned that. That's where your optimal quantity is. But the price for perfect competition, that's a different story altogether. You just take that price from the market, and then hopefully it's going to be high enough to cover your costs and legit make you want to stay in business. But for monopolists, the pricing decision, there is no market to determine the price for you. You are the market. That's why we need that demand curve. So, because this right here helps, this is why you can't just charge infinity. Your demand curve, your market demand curve that you face is the market demand curve, which means if you want to sell more, you have to drop your price. If you want to sell if you want to have a higher price, then you have to sell less. You're following that market demand curve. Once you figure out your optimal quantity, you're charging the price on that demand curve. So this summarizes everything we've said so far. Marginal revenue curve is always going to be below the demand curve, and you're going to have to be able to recognize it as a downward sloping curve that looks like a demand curve, but is always below the demand curve. So as I said, we're going to see it again. Marginal revenue equals marginal cost. This is where you maximize your profits always. We went into that with perfect competition. So this is a more generic looking pure monopolist graph. Downward sloping demand curve that looks like the market demand curve, because it is, and a marginal revenue curve that looks like this, and we already saw why that is. It's always going to be the case. So let's add those other cost curves in. Now again, remember I said that these are always going to look like this no matter the industry, because when we determine costs, it doesn't matter the market you're selling your output in. What matters is how much does a bag of sugar cost if you're a baker? How much do your labor inputs cost? How much does your machinery cost? The space you're renting out, how much does that cost? None of that has to do with the output market. So these curves are always going to look exactly like this. They're going to look the way they're going to look based on your costs, of course, but you're going to have a marginal cost curve that slopes up like this. Average total cost comes down for a while and then comes back up. Average variable cost, it's always under average total cost. Again, we've gone into all of this, but these cost curves always look like this. The difference between perfect competition and pure monopoly is that the demand curve and marginal revenue curves are not the same curve, nor are they the same as any one price. It's the market demand curve and a marginal revenue curve that's always below it, but then everything else falls into place in the same way. You may already have noticed this is your optimal quantity. Marginal cost equals marginal revenue. In perfect competition, you still wouldn't necessarily charge this price. You charge the highest price the market can bear. And here, that's right here. Now remember, with perfect competition, we took this demand curve for the market, and then we had a graph next to it that had that price line at the same place, but it was the market demand curve that was determining it. It's the same thing here, only here we put them all on one graph. But this is the optimal price. If you're a rational profit maximizing business, why would you charge a price that's lower? You wouldn't. And if you charge a price that's higher, you can't sell all of these units, as we saw on the previous slide. So this is your optimal quantity, and this is your optimal price. Now, a couple more things we need to figure out from this graph. One is, what is your profit? Well, remember from perfect competition, if you charged a price above average total cost, you made a positive economic profit. Price equals marginal cost equals marginal revenue equals average total cost is a long-run outcome in perfect competition. Price equals average total cost means you have zero economic profit. But notice here, the price you want to charge, this demand curve, is above the average total cost curve. So you can have positive economic profits. All right, got to get that annoying thing out of there. And you can see that positive profit in this box right here. The average total cost is where you have zero economic profit. That's the cutoff. And then the price PM here is price for monopolist. This is the highest price the market will bear. And everything in this box, this is the total profit that you're going to get, because this is all the quantity that you're producing multiplied by the price. But you don't have this big square here because you have all your costs taken out down here, and this is your profit right here for a pure monopolist. And you see it in that box, and you are going to have to know this for exam purposes. It's this area here, this box, that coincides with the average total cost. If you draw a line from your optimal quantity all the way up to the demand curve, if it passes through the average total cost curve, you have positive economic profits. And it'll be a rectangle that's defined by these boundaries. So to that question, I did mention that pure monopolies don't always make an economic profit. And we're going to see why. What if economic conditions change? You had a good or service that a lot of people liked, but then let's say it fell out of fashion. Notice here, the demand curve is under the average total cost curve at every point. So your optimal production point here is right here. You want to produce this amount. Your optimal price is here. You can't charge more than this. If you charge more than this, you're not going to sell all of your output, and that's costs you incurred for units you won't sell. That's a bad thing. You don't want that as a business. You want to sell. If you put costs into producing something, you want to sell all of it. Doesn't happen in a perfect world, but that's generally what you want. So if you raise your price, you're going to sell less. If you lower your price, you'll sell more, but you're at a point where your marginal cost is higher than marginal revenue. So this is your optimal quantity in the short run. In the long run, you're going to exit this industry if prices don't recover, if demand, which guides your prices, don't recover, because your average total cost, this is where you make your profits. So we put it all together and see that this right here is going to be your total loss as an economist. As a monopolist, this is going to be your total loss. It's not going to be anything below this curve. Of course, the shutdown point is right here, because again, your price is right here, but this is where your price needs to be in order to break even, and you're not breaking even. So this is the amount that you're essentially losing. And that is why monopolists don't always make profits. So we'll talk about allocative efficiency in another video, because again, I want to keep it under